Hi guys, welcome back to our mathematics tutorial. This is question number 20 on the implicit differentiation and natural logarithmic functions. So we can use the natural logarithmic function to assist us in finding the derivative of this equation using implicit differentiation. Now, like we said in previous lesson, this is not possible to use power rule. That is, we bring this power down and subtract 1 from the power. It's not possible to use power rule. The reason is because the powers are not real numbers, or the powers are not just number, any number, right? The powers are functions and not just numbers. So we cannot use the power rule. Additionally, our main focus in this problem first must be how we can get rid of these powers, how we can bring these powers down so that we'll be able to find the derivative of this function. So to do that, we have to bring in logarithmic functions, because we know that the ln of a raised to r is equals to r the ln of a. So if we take the ln of a particular function, the power of that function will have to come behind the ln. So that's one of the ways that we can get rid of these powers. And another thing is that we cannot just take the ln on both sides of the equation, because if we do that, it means that we will be taking the ln of this entire function, or even if we send this y across, we'll be taking the ln of this entire function. And there's no property of the ln that allows us to bring these exponents down when we have the ln of x raised to the power ln of x plus ln of x raised to the power x. So we do not have a property for something like this, ln of a plus b. We do not have a property for it, but we have a property for the ln of a divided by b, which is the ln of a minus the ln of b. We have a property for the ln of a times b, which is the ln of a plus b. We have a property for the ln of a raised to the power r, which we have there, r the ln of a, and so forth. So what we need to do is that we need to deal with this problem, or we deal with these terms within this problem separately. So we can say let r equals to x raised to the ln of x. So we take the first term to find its derivative. We find the derivative for the second term, and then we're going to find the derivative for the third term and just be able to solve for y prime. That's all. So the derivative of the first term. Now we want to get rid of this power, so we take the ln on both sides. Ln of r equals to ln of x raised to ln of x. So this power now will drop according to that property. So we have the ln of r is equals to ln of x times the ln of x. But now, like you have x times x equals to x squared, and you have sine of x times sine of x equals to sine square x. Likewise with the ln. So the ln of x times the ln of x is equals to the ln of x all square. So you put the square on top of this n and not on top of the x. So we can rewrite it as ln of x all square. Now let's find the derivative, or we can say ln of x all square. Let's find the derivative. So the derivative of this ln of r is 1 over r times the derivative of r, which is just r prime. The derivative of ln of x raised to the power 2. You bring this power down. Now we can use the power rule, or we say the extended power rule, because the power now is a number. So we bring this 2 down, rewrite ln of x, subtract 1 from this power now, we just get 1. Then we differentiate inside. The derivative of ln of x is just 1 over x times the derivative of x, which is just 1. So now we have r prime equals, so we can cross multiply, that is multiply this r by this expression. So this will now be r 2r times the ln of x all over x. What is r? From the beginning, r was, so we have x, 2x raised to the power ln of x times the ln of x all over x. So this is the first derivative. So we hold on to the first derivative and find the derivative of the second term. So we say let p equals to the ln of x raised to the power x. Again, we take the ln on both sides. And then what happens? We differentiate, let's say bring this power down first, ln of p, x, ln of x. So we differentiate, so it's 1 over p times the derivative of p, which is just p prime, equals, we also have two functions right here. So we hold the first function x, and we differentiate the second function. So the derivative of ln of a function is just equals to 1 over that function, which is ln of x, times the derivative of that function. So what's the derivative of ln of x? Is 1 over x, times the derivative of x, which is just 1. Now what do you observe? X and x cancel. Now plus, since we held this one and differentiated this, we need to hold this one now, ln of x. And the derivative of x is just 1. Now we're going to multiply this p by this expression on the right. So we have p prime equals, if we multiply it, we're just going to have ln of x raised to x, because this is p, times this expression. So what is this one? It's just 1 over ln of x, then plus ln of x. So this is now our p. This is our p prime, this is our r prime. So the derivative of the first term and the derivative of the second term. Now we can just rewrite our final answer. So we do have the derivative of the first term, which is this one, is now 2x raised to the power ln of x times ln of x all over x. And then plus the derivative of this term is just ln of x raised to x, and then times 1 over ln of x plus ln of x. Now we send this y across, it becomes positive y. The derivative of y now is just y prime. So we can call this our final answer. Or if you like, you can further simplify this x and this x, because we know that a raised to, let's say x raised to the power a divided by x raised to the power b is equal to x raised to the power a minus b. So our a is ln of x and our b is just 1. So we can rewrite it as 2x raised to the power ln of x minus 1 times the ln of x plus ln of x all raised to the power x times 1 all over ln of x plus the ln of x, all equals to y prime. Now what do you also observe? We can also simplify this thing further. Now this ln of x, we can send it in the numerator. It will be ln of x raised to the power minus 1. So if we to just multiply this and this and this and this, but it doesn't really matter. Let's just leave this one. So it's 1 all over ln of x, because we have two terms in this. So let's leave it. Now for this one, we can also rewrite this 1 such that at least both terms in there can be ln. So we know that 1 is just equal to ln of e. So the ln of e is just 1. So if we rewrite this as ln of e, what's going to happen? If this is ln of e, we're going to find out that ln of x minus ln of e, ln of a minus ln of b is equal to ln of a all over b. So this can now be 2x raised to the power ln of a, which is x, all over b, which is e. And then times the ln of x plus ln of x raised to x multiplied by 1 all over ln of x plus ln of x, all equals to y-prime. So we're just trying to rewrite this expression, but this is our final answer. So this will also be our final answer depending on what exactly you want. So thanks so much for watching. See you in our next lecture. Please don't forget to share and subscribe. Thank you.